So on page 14, I gave you this little graph, right? We got my function f, and then let's go put this little point of tangency here at a. Boop. It's got that point of tangency. And let's go give that a point. Let's go name it. If my x value is a, what would my y value be? Agreed. Oh, third period, there's nothing that makes me happier than your responses. That's that point. So you guys, all we got to do is they're always going to say, hey, what's that tangent line equation? You're like, okay, cool. Point slope form all day. So it would be y minus, what's my y at this point? Yes, people, you amaze me. What's my slope at that point? F prime of A or M, they're the same thing because we're little calc geniuses now. We could write F prime of A, but if you'd rather write M, write M. We just know it means slope. And then x minus, what's my x value here? Done. So that is going to be the equation of my tangent line that we have to do for every problem. They're going to want that for every problem. And then if we have the equation of that tangent line, okay, peeps. So what I tried to give you a picture of was what I had on that Desmos thing. Here's a function. Why am I having you look at this crooked? Here's a function. And then all I did here is I zoomed in. Check this out. You agree that the function has this point, 1, 3. They share that point. And then all I did is I zoomed in, and look what happens. This red point is here as I zoom in, and that red point's here. At the x value, again, green line is tangent here. The green line is the tangent value. Is the y value of my tangent line going to be pretty close to the y value of the function, which is my red one up here? It's going to be pretty close, and they just want to know, okay, what is the y value of the tangent line? Because I know it's going to be pretty close to the function. That's it. I don't really, why do we care? I don't know. But AP is going to ask us, so we're going to practice it. Okay, so check it out. This is how they're going to ask that question. For a differentiable function, we know a point on that function. Oh, snap. And we also know a slope at that same x value. So we know the point on the function, and we know the slope. They're saying using the tangent line. Let's just stop right there. Go write me the equation of the tangent line at that point. Okay, what's the equation of that tangent line, y'all? Y minus 7. Is my slope -3 times x minus 2? Nope, we haven't done anything yet. Is this still the equation of the tangent line? Can I just throw that 7 over there? Okay. This is the equation of the tangent line. They said use that to approximate when x is 2.1. So that's it, my girlfriend. That's all we got to do. We got to say, all right, they want 2.1, an approximate when x is 2.1. Here's how we write this. I wouldn't worry about too much of the notation, but this is how they like it. F of 2.1, because that's what they want, is approximately. So we're saying ish. If you don't put f of 2.1 and you don't write the ish, that's okay. What do we need to write? We just need to go plug in my 2.1 right there. So we're going to say -3 times 2.1 minus 2 plus 7.
Can you expand that out though? Can we mx plus b?
Oh, you could, but here's the deal. We're done. Okay. Let's not. You know what I mean? The fewer the steps, the less mistakes we'll make. So we're going to leave it in point slope. And let's just plug in my 2.1. If this was multiple choice, which is important to practice, what would this decimalness happen? What would happen? F of 2.1 would be about -3 times 0.1 plus 7. -3 times 0.1 would be -0.3 plus 7. Final answer, 6.7. So the y value when x was 2 is 7. We're saying the y value when x is 2.1 is going to be about 6.7. Again, why do we care? It's just that we can give them this approximation even without knowing what the function is. Cool. I don't think that's that cool, but that's what they want us to do. If this was free response, y'all, we end right here. Can we do the same thing here? Hey, I gave you a table. Write the equation of a tangent line. Let's just start with that when x is 4. I'm not even going to finish that sentence. What do I need to write the equation of a line? A point and a slope. What would be my point?
4, -5.
4, negative 5 is my point. I'm just going to write that out. What's my slope going to be? Yeah, f prime of 4 is going to be 6. I just got that from there. You don't have to write this out here if you don't need it. What would be the equation of that tangent line? Oh, y plus 5. Gorgeous. Gorgeous, you guys. They said use that to approximate when x is 3.8. Exactly. I'm going to say f of 3.8 is going to be about 6 times 3.8 minus 4. And then Soph said, don't forget to move that 5 over. That's exactly when I do it. I don't write it again in the middle. You can, but I think y'all are smart enough to be like, I just got to move that over. We're done. If it was multiple choice, what's 3.8 minus 4? Negative 0.2 times 6. Act like it's just 6 times 2. 12, and then move that decimal over 1, and we'd be at negative 1.2 minus 5. If it was, negative 6.2. Thanks, Kyle. I wrote negative 6.7. You just saved me. This stuff on page 15, again, this is just kind of, again, let's just talk about what this would mean. If I were to look at this picture, do you think my tangent line's approximation would be an overestimate or an underestimate of the actual value of the function at that same x value? It's going to be an overestimate because it's above it, right? So let's just write that over here. There's going to be an overestimate for A, and we could just even circle that. Again, this is just kind of laying some groundwork for the next unit. We're not going to use it too much today. What about over here? Do you think my tangent line's estimation is going to be an over or under? Agreed. This is going to be an underestimate. And we could just circle that. Boop. Okay. Then what I want to teach you a new word today. On this graph, what would you say my f prime is here? Positive. What's my f prime here? And then what's my f prime here? So if I went from a positive to a 0 to a negative, do you feel comfortable saying that my f prime is decreasing at all times in pink? It was positive, but less positive to 0 to negative to more negative. Doesn't it just keep getting smaller? It's kind of funky. So here's what I want. This is a new word. This region here, because my f prime is decreasing, we say that graph is concave down. F is concave down. It's concave down there. What about my my tangent line? All those tangent lines would be over or underestimates. They'd be overestimates, agreed. Wait, we don't need to write that. Concave down. Here's how I like to help myself remember that. Concave down. Don't you agree that this kind of looks like an N in concave down? Okay. What do you think this one looks like? U for concave up, right? Okay. What do you think my f prime is doing here? Ooh, it's negative, but then it's, so if it's negative, but then less negative and 0 and then positive and more positive, it's always increasing, right? Which I think is a little funky to say. So we'd say f prime is increasing here. And their f is concave up for you. And maybe on your page, because you don't have these fancy markers, maybe you do something like this. It's where it's concave up. And then maybe you do like dots. This was where it's concave down, something like that to help you see. Okay, so now we have a point and a slope. They said use the equation of the tangent line when x is 2. What's that going to be? Y minus equals x minus. Oh my gosh, I want to weep. Now they said use that to approximate f of 2.1. F of 2.1 is going to be about 10
times
2.1 minus 2 plus 7. We done. Okay, so on 2008, this is the legit question. Was anyone not born in 08? Whew, okay, here we go. They gave you a point.
Yeah.
They gave you a slope. To Carrie's notice, they also gave us the second derivative. They said, what's the value of the approximation at 1.9? I really wish that they put this in a different order, because then they said, using the tangent line when x is 2. Oh gosh, that's a me problem again. That should be f double prime of 2. Oh my Lanta. Can we first go find the equation of the tangent line? Yeah, y minus is my slope times x minus, beautiful. We got the tangent line. They said, what's the approximation of 1.9, which is close to 2? You guys were going to say, all right, f of 1.9 is about 4 times 1.9 minus 2. Throw a plus 1 on there. I agree, Greer. That's hard to say. Agree, Greer. I agree, Greer. Okay. What's 1.9 minus 2? Negative 0.1. Add the 1. Negative 0.4 plus 1 is 0.6. I love it. Okay, here we go. They gave us this function f. What is the approximation when x is 1.5? Okay. Using the tangent line when x is pi over 2. We got to plug in pi over 2. We got to go find f of pi over 2. Ew. 2 cosine of pi over 2 plus 1. Where's that pi over 2? Whoosh. Cosine there is 0. 2 times 0 is just 1. Awesome. When x is pi over 2, my y is 1. I just kind of like to throw that point off to the side, so I've got it. You settle down. That's right. You guys, how am I going to find the slope? F prime. Okay. F prime of x, derivative of 2 cosine. Guys, I mean, wow. Derivative of plus 1? We don't worry about it. Very good. Where do we need that derivative when x is? So we got negative 2 times the sine at pi over 2. The sine at pi over 2 is 1. Multiply that by your negative 2. You got negative 2. I got a point and a slope. Let's write it out, girl. Y minus 1 is my slope. X minus, beautiful. They said, using that tangent line, we did it. Approximate 1.5. Nah, I know it's not great, but we got it. We got negative 2 times 1.5 minus pi over 2. Throw a plus 1 over there, right? And I know that this looks uglier because before we were always able to distribute that. Sorry, we didn't distribute before. Could I distribute now? Because it's multiple choice. Yeah, I'm with you, Soph. Yep, that's okay. Negative 2 times 1.5. It's negative 3. Negative 2 times negative pi over 2. Plus pi. You guys good. Plus 1. Agreed. Is that an answer? You got it, dude. Okay, so our homework. We're doing pages 11 and 12. I'm going to throw those answers up here.